Okay, so flipping over, we have example 2. The shape of a bridge can be modeled by y equals 25 minus x squared. So, here are my x values that they want me to put in. This is my equation. So it's y equals 25 minus x squared. So substituting negative 3 into my x, I'm going to zoom in so that you can see exactly what I'm doing. So subbing in negative 3 into my x, I get 25 minus negative 3 squared, which is 25 minus 9, which is 16. Putting in negative 2, 25 minus 2 squared is 25 minus 4 is 21. 25 minus negative 1 squared is 25 minus 1 is 24. 25 minus 0 squared is 25 minus 0, 25. 25 minus 1 squared is 25 minus 1 is 24. 25 minus 2 squared, 25 minus 4 is 21. 25 minus 3 squared, 25 minus 9 equals 16. Now, did you see what I saw? I went from 16 slowly up to 25, and then I slowly came back down to 16. This is not linear, is it? I'm going up to a maximum, and I'm coming back down. So now I want to graph my data. So why don't we put my axes here. Why don't I make this positive 1, 2, 3. Make this negative 1, negative 2, negative 3. So this is my x-axis. I'm going to zoom out a little bit. This is my y-axis. Now I got to go up to 25, and my smallest one is 16. So I'm certainly not going up by ones. How be if I go up by 4, 8, 12, 16, 20, 24. That's not bad. Go up by 4s. 4, 8, 12, 16, 20, 24, 28. Let's plot our points as best we can. Negative 3, 16, negative 3, 16, negative 2, 21, negative 2, 21, so it's a little bit above the 20, negative 1, 24, 0, 25, 1, 24, 2, 21, and 3, 16 again. And lo and behold, look what we got. We have the bridge. There is your bridge. The question below says identify any x-intercepts and any y-intercepts. Well, the bridge is going to have to continue coming, isn't it? It's going to continue down there. And it's going to continue down there. Now my scale is really, really lousy for figuring out what those values are, isn't it? My scale stinks for that. Maybe I can use my equation to help me. For an x-intercept, we know that y must equal 0. So if I take this equation, y equals 25 minus x squared, can you tell me, just by looking at it, what value of x will make this into 0? Any ideas? What value of x, if I plug it in, if I square it, will make 25 subtract that 0? Okay, if we can't come, Emma, yeah? It's 5, isn't it? And it doesn't matter if it's plus 5 or minus 5, because when I square it, it'll work, right? So if I do this, I get 0. And if I do this, I get 0. So my answers are, it's going to cross out here at negative 5, and it's going to cross up here at positive 5, which means my x-intercepts are going to be negative 5, 0, and 5, 0. Now, I could have redone my graph and read it from my graph, or that wasn't a bad way of thinking about it, was it? What number could I put in there to give me those values? Okay, those are the x-intercepts. What about for your y-intercept? Can we see that on the graph? Yeah, we can. There's my y-intercept. That's where it's crossing the x-axis. So that's going to be 0, 25. So your y-intercept is 25. So we found your x-intercepts. We found the y-intercepts. What about the vertex? Well, the vertex is where it changes from increasing to decreasing or decreasing to increasing. That's right here. Our vertex is also your y-intercept. That's okay. That happens. The vertex is going to be 0, 25. And finally, they want the equation of the axis of symmetry. The axis of symmetry cuts right through the vertex. And it's going to be x equals 0. And notice, it's the same as this value here in the vertex. So your axis of symmetry is always going to be x equals a number, and it's always going to be this number because it crosses through your vertex, always. So it's going, in this case, it's x equals 0. And a pause the video there, and we'll be right back.